So we are basically going to discuss the anti-logs and some basics log property. So first of all, let us see the graph of the log, right, to get some concepts. So this is basically x-axis and this is the y-axis, and this is basically the log graph. And basically what is this? This is x is equal to 1. It means when the x is less than 1, x is less than 1, the log x value will be negative. But when, see, this is the y axis, like x is equal to some less than 1, if we are taking the values, we are getting the negative values in the y axis. Now if we are taking the x value greater than 1, like 2, 3, 4 and so on, like 2, 3, 4, so in the 2 we are getting the values to be 0.3, means when we are taking x greater than 1, then we can say that the log x value is a positive number. Right. Now we have to remember some properties like log of a into b. So this is basically log of a plus log of b. Log of a by b is basically log of a minus log of b. Then some values you have to remember for the physical chemistry that we require. So now log 0.1, so 0.1 is less than 1, so the value will be negative. Now how to solve it? So 0.1 can be written as log of 10 power minus 1. Now another one property that we have to remember is log of a power x is equal to x log a. So what is this? 10 power minus 1 is basically x. So you can write is minus 1 log 10, and the log 10 value is 1, right? So this is basically minus 1. So we can solve like this. So some value you have to remember directly, that is log of 0.1 is equal to minus 1, log of 0 log of 1 is equal to 0, log of 2 is equal to 0.3103. Then we are having this is log 3 value, we get 0.47, log 4 we get 0.60206. Basically you have to just remember by this, log 4 we can directly say it is approximately 0.6, it can be said approximately 0.48 we can say, and this is basically approximately 0.3. Then we are having the log 5 is equal to, we can say that is 0.69 or approximately it is 0.7. Then we are having the log 6 value, then log 7, then we are having this is the log 8, log 8 we are getting that is 0.9, then log of 9, then log 10 we know that it is 1. Now let us if we forget some values, like let us remember that we don't know the log 4 value, so how can we find in the exam? So log 4, let's solve some question, right, like log 4. So can we write it as log into 2 ka square? So this 2 will come out 2 log 2. Now we have to remember the log 2 value, that is 2 into 0.3, so it is 0.6, right? Or you can use another method. There are various methods to solve the same question, right? Like you can solve like this also. Log of 4 can be written as log of, that is log 4 can be written as log of 2 into 2, So it can be written as log 2 plus log 2. We are using the property, right? Log a into b. 0.3 plus 0.3, we get 0.6. You can solve all the values, but you have to remember the basics, like this is log 1 value, log 2, log 3, or you can actually remember up to 10, because this is very useful for a physical chemistry, right? Will carry. Now what is the anti-log? That is the basic thing that we require. That is the concept that get used in the physical chemistry, that is the anti-log. So anti-log, so I am giving it not going into the complex. I am just giving simply how to solve, how can you solve the question, right? So basically what you say, that is if we are having like log x. Now when we are writing the log, basically uh, when we write log, then it is basically here is the base 10, and if we write ln, then base is e, right? So let log as this is 10 is equal to y. Now shift this base, this is just a way to remember, shift the base here, so it will come down. So x is equal to 10 power y, we can write. So this is the concept that I am going to use in the log anti-log, right? So like if we are talking about the log 2, so it is values 0.3, this is the base 10, right? So 10 power 0.3, so shift it here, so 2 is equal to 10 power 0.3. It means 10 power 0.3 can be written as 2, right? Similarly, if we are having the log 3, so it is 0.47, this is 10. So if we say 10 power 0.7, log base 10 3 is equal to, we are having 0.47, right? So shift it here, 10 power 0.47 can be written as 3. So now we'll go for some examples like that we required in the physical chemistry to solve the question. Like we are having 10 power minus 3.31 is given, and we have to calculate its value, right? When we're calculating the pH, pOH and all this, we require it, kW, pKw and all this. So you have to calculate this value. So I will simply give a trick. So this is the 10. Now there is a 3, right? Just plus 1, so it is minus 4. Now this is 31, right? So 100 minus 31, so it is 0 point, that is 69, right? 69, eh? So just write it here, 10 power, just add a point and write this number 69. So it is basically 10 power 0.69. Now find out the log value for find out for which this is 10 power 0.69. So which log value is 0.69? So it is basically log 5. So log 5 is equal to 0.69. So we can write as 10 power 0.69 is equal to 5. Simple. So it is 10 power minus 4 into 5. So we get the answer of 5 into 10 power minus 4. Another example I am trying, that is 10 power minus 4.65. Simply write 4 plus 1 what? 5. 4 plus 1 5, 10 power minus 5, 100 minus 65 into 10 power 0.35. Now 0.35 correspond to which value of log? So 0.35 is basically in between log 2 and log 3. We know that log 2 is 0.3, log 3 is 0.47. Now basically what log 2 and log 3, 0.47 is far away from 0.35. So the answer is basically lying from like 2.1, 2.2, 2.12. Let's consider it is, approximately we are finding it that it is 0.3. If it is log 2, then log 2.1 or log 2.2 value will be 0.35. Since we know that the log is an increasing function, as the see the x is increasing, the value of the log is also increasing, means the value of y is also increasing, right? As x increases, the value of y also increases. So log 2 is 0.3 and we require 0.35. So log 2.1, log 2.2 maybe correspond to this value. So let us consider it as 2.2 into 10 power minus 5. So this is the answer that we got from this. Hope you understood well.